Hi, quick update. So one of my friends watched my earlier video and said that I didn't do a complete job in solving this problem. So let me read this problem out for you again. X, Y, and Z are three real numbers such that 3x, 4y, and 5z is a geometric sequence, and 1 over x, 1 over y, and 1 over z is an arithmetic sequence. Find the value of x over z plus z over x. And I will explain what I did in the last video as we go through my solution in here. My solution was to replace the 3x, 4y, and 5z with other symbols. So, for example, A 3x, A equals 3x, B equals 4y, and C equals 5z. And from this we know x equals A over 3, y equals B over 4, and z is equals to C over 5. It's all good. So I then made another sequence with A, B, and C in mind. A, B, C. So that's easier to read. And then for the arithmetic sequence, this is now going to be 3 over A, 4 over B, 5 over C. This is similar to the one I worked on earlier so far. So now, in that video, I assumed that A equals B equals C. Assume A equals B equals C. Uh, This is just an assumption. This is not a fact. Maybe there's another geometric sequence that could work that doesn't involve setting them up as the same number, right? So how can we find that? Well, a geometric sequence is a sequence wherein you multiply a certain common ratio to get the next number. So, for example, you have the first number 2. This is your first number. And then you multiply it by some common ratio. Let's say 3. This is going to be your common ratio. So the next term would be 6. And then multiply that by 3. So the next term would be 18. 18. There you go. Not 9. Okay. So a first number in a common ratio. Let's apply that here. Let's set A as the first number. So then we have to multiply that by a common ratio. We don't know what the common ratio is yet, but we do know that it is a common ratio. So let's denote it as R. So A times R is going to be AR. AR times R is going to be AR squared. Now what does this do for the arithmetic sequence? Look at this. 3 over A remains 3 over A. 4 over B, well, B is now equal to AR. So that's going to be 4 over AR. 5 over C becomes 5 over AR squared. Now, let's make the denominator the same number. So, AR squared seems to be the LCD, the least common denominator. So, let's put AR squared on the denominators for each of them. In here, we have to multiply by 3 R squared. We have to multiply by R squared on the top so that uh, 3 over A and 3R squared over AR squared is the same thing. In here, we have to multiply by R, so this becomes 4R. In here, we don't have to multiply by anything, so it's just 5. Easy enough. Now, the trick here is to make another arithmetic sequence, but this time, let's remove the denominator. So, the arithmetic sequence that we now have is 3R squared, 4R, and then 5. Now, an interesting property of an arithmetic sequence is that this minus this is this minus this. So this equality holds true. 5 minus 4r equals 4r minus 3r squared. All right? The proof that is this. So a geometric sequence has the first number, like last time. This is the first number. Let's say this is like 7. Right? We have to multiply it by a common ratio. So maybe this is a plus t. Maybe the common ratio is like 3. We have to multiply 7, we have to add 7 by 3. So we have, this is going to be 10. The next term is going to be plus 3 again, so 13. In here, it's a plus 2d. All right. Interesting thing to note here is that 10 minus 7 is 3, and 13 minus 10 is also 3. So 13 minus 10 equals 10 minus 7. 3 equals 3. This is the same. In short, a plus 2d minus a plus d equals a plus d minus a. If you do the math here, you get d equals d, which is the same. So this holds true. Now, how do we solve for r here? Oh, this is a quadratic equation. We just move everything to the other side to go there. So negative 3r squared becomes 3r squared. Uh, Positive 4r becomes negative 4r here. Negative 4r minus 4r is going to be negative 8r. And then plus 5 equals 0. Now from here, this is just a quadratic equation. You can use any method you want, but I will show you a method that you can use. If there is a multiple in here, first step is to mu multiply this number by that number, basically just transferring it temporarily. This is not the equations. And then doing the no usual things you do in solving this. I will use the crisscross method like this. This is going to be 5 and 3. So 5r and then 3r. Would that make negative 8r? No. But if I put negative and negative here, this would make negative 8r. In order to do that, I will put negative here and negative here. So our equation then becomes r minus 5 and then r minus 3 equals 0. Now, since we divided this by 3, we now have to multiply both of these by 3. At least we have to multiply this, the r, by 3. So this becomes 3r minus 5 and then 3r minus 3. Now, what we do here is if there is a common factor, for example, here the common factor is 3. This can be factorized as 3, then r minus 1. We just remove the 3 here. So the final expression becomes 3r minus 5, r minus 1 equals 0. That's the trick. All right. So from here we can get that r is equals to 1. From here, r equals 1, which is the thing we discussed in an earlier video when I said that a and b and c are the same number. It means that the common ratio is 1. And here we found that the common ratio can be 1, but it can also be 5 over 3. Now, what are the implications of that? We will see later. So what does this mean? So now let's make another geometric and arithmetic sequence. All right. So A, B, and C earlier here, uh, A, B, and C here became A and AR squared. So we will now copy that. A, uh, and then AR. We will set R be equal to this. So A times R or A times 5 over 3, 5A over 3. And then AR squared. R squared is going to be 25 over 9. So that would be 25A over 9. This is going to be A. Let's just make that obvious. That is A. This letter. Right? So and then what happens? We know that this is A and this is equals to C. What is X in terms of A? Let's go back earlier. X is equals to A over 3 and Z is equals to C over 5. So X equals A over 3 and then Z is equals to C over 5. Now C became this. So C over 5 became 29 over 9, 25, sorry, 25 over 9 times 1 over 5A. So the 1 over 5 came from here. We have to cancel this out, and we get 5. So Z is now equal to 5A over 9. For X is just A over 3. So yeah. Now what we need is X over Z plus Z over X. This can be, you can use the crisscross method here in order to get x squared plus z squared over xz. Let's plug in x and z into this. So x was a over 3, so a over 3 quantity squared plus 5a over 9 quantity squared over a over 3 times 5a over 9. All right, let's expand this. So a squared over 9 plus 25a squared over 81 over, this is going to be 5a squared over 27. All right. So let's try to find the lowest common denominator of 9 and 81. That's going to be 81. So 81 here, and then in order for this to be 81, we have to multiply both the numerator and the denominator by 9. So this becomes 9a squared plus 25a squared over 81 all over 5a squared over 27, right? So now we have to multiply by the reciprocal of the denominator in order to make this simpler. All right? 9a squared plus 25a squared is 34a squared, then over 81, multiplied by 27 here over 5a squared here. A squared, they cancel each other out. 2781, they cancel each other out. 2781, this becomes 3, since 27 times 3 is equals to 81. 34 remains 34 on the numerator. 3 times 5 is 15 on the denominator. And look at that. We got 34 over 15 again. Doesn't matter if the common ratio was 1 or 5 over 3. The answer is still 34 over 15. And I thought that was marvelous. And I'll see you in the next video.